So, yesterday we built the first quadrant of the unit circle, and we saw that there are some key points on that unit circle that we use, some key stops on the unit circle. We can start again on the positive x-axis. Remember that your unit circle starts in what's known as standard position, which means the initial arm starts on the positive x-axis. And because it's a unit circle, that's a circle with a radius of 1, at 0 degrees or 360 degrees or 0 radians or 2 pi radians, those are all coterminal angles. The point there is the point 1, 0. And we saw that those numbers tell us the cosine of those angles and the sine of those angles. It's always in the order cosine theta, comma, sine theta. So that's what we saw. Up here at 90 degrees, or pi on 2 radians, the coordinates are 0, 1. Again, because it's a unit circle. To get to that point, you don't go left or right, you go up 1 unit. And that tells us that the cosine of pi on 2 radians is 0. The sine of pi on 2 radians, or 90 degrees, is 1. Then we did pi on 4 radians, or 45 degrees. That's halfway between 0 and 90. Right, so this was pi on 4 radians, or 45 degrees. And we saw the coordinates there were root 2 over 2, comma, root 2 over 2. Initially that came from 1 over root 2, which we then rationalized. And remember, you can use the hand trick to get that. Right? Left hand, palm forward. This is 0. This is 30 or pi on 6. This is 45 or pi on 4. This is 60 or pi on 3. If you want to know what is happening at pi on 4, which is this middle angle, put that down. It's the root of this many fingers over 2, comma, the root of this many fingers over 2. Root 2 over 2, comma, root 2 over 2. That's where those values come from. They actually came from those special triangles, but using the hand trick, that's how you get them. And this again tells us that the cosine of 45 degrees, or pi on 4 radians, is root 2 over 2, and the sine is the same value. And then we said, okay, you can find the cosine of theta, the tangent of theta, by using this trig identity that tangent equals sine over cos. So if we write the tangent in black at 0 degrees or 360 degrees or 0 radians or 2 pi radians, the tangent is sine over cos, 0 over 1, which is 0. At pi on 2 radians or 90 degrees, the tangent is 1 over 0, sine over cos, which doesn't exist, undefined. At 45 degrees or pi on 4 radians, because the cosine and the sine are the same values, when you divide them, you get 1. The tangent is 1. Right? Then, if we do pi on 6 radians, or 30 degrees. So this is pi on 6 radians, or 30 degrees. So that is the second finger, right? The first finger is 0. The next stop is pi on 6 radians, or 30 degrees. So it's the root of this many fingers over 2, root 3 over 2, comma, root 1, which is 1 over 2. So that's where those values come from. This tells you the cosine of those angles and the sine of those angles. So again, what this is used for is your calculator will give you the values, but it'll give you the values as a decimal, not an exact value. If you want the exact values, you must use the unit circle or those special triangles. But we use the special triangles to create the unit circle. So again, if our calculator is in degree mode, so let's use degrees. If we take 0 degrees or 360 degrees, the cosine of 0 is 1. That's that first number. The sine of 0 or 360 is 0. That's the second number. At 90 degrees, the cosine of 90 degrees is 0. That's that first number. The sine of 90 degrees is 1. That's that second number. And if you take the tangent of 90 degrees, you'll get an error. It doesn't exist. It's undefined. Okay? So the calculator will, for those angles, give us the actual exact value. But if we did 30 degrees and we take the cosine of 30 degrees, it gives us a decimal because it is actually an irrational number. So using the calculator, you get an approximate answer because you have to round that at some point. But using the unit circle, you get an exact value. That 0.860 comes from root 3 over 2. So if you do root 3 divided by 2 in your calculator, you get the same value. But now we see where that decimal comes from. It comes from root 3 over 2. Now the sine of 30 degrees is 0.5 or 1/2. So your calculator will give you that as an exact value because 0.5 is a terminating decimal, but not the cosine of 30 degrees. So in the same way, at pi on 4 radians or 45 degrees, let's just change our mode to radians because you should be able to work with both. The only time the mode matters is when you're taking the sine, cos, or tan of an angle. If the angle's in radians, you have to be in radian mode. Are you with us, Leo? But if the angle's in degrees, then you need to be in degree mode. And that's really the only time that the mode matters. If you're taking the sine, cos, or tan of an angle, the mode has to match what unit the angle is in. So I changed to radians, so now we can take the cosine of pi on 4 radians. It's that decimal. It's an irrational number. Using your calculator, you would have an approximate answer because you need to round that. But where does that come from? Well, we now know that the cosine of 45 is root 2 over 2. If we do root 2 and divide it by 2, that's where that decimal comes from. Root 2 over 2 is the exact value for the cosine and the sine of pi on 4 radians. Right? So that's what we use the unit circle for. So our last stop was pi on 3 radians or 60 degrees. So that's up here. And on your hand, there's your pi on 3 radians, your 60 degrees. It's the second last stop because the last stop is 90. So there's 60 degrees or pi on 3 radians. It's the root of this many fingers over 2, root of 1, which is 1 over 2, comma, the root of that many fingers, root 3 over 2. It's the same two values from pi on 6, just reversed. Here the 1/2 comes first, the root 3 over 2 comes second. So this tells us that the cosine of pi on, and I should write those on there, this was pi on 3 radians or 60 degrees. The cosine of pi on 3 is exactly 0.5, so your calculator gives it, it's a terminating decimal. So you could get that from the calculator, but the sine of pi on 3 then is an irrational number. That 0.8660 comes from root 3 over 2. We saw that when we looked at 30 degrees. right? So when you're asked to find the exact value of the sine, cos, or tan, and let's go back first and write the tangent of these two. Remember, tangent is sine over cos. So for pi on 6 radians, or 30 degrees, the tangent would be found by going sine divided by cos. To divide by a fraction, we multiply by the reciprocal. The 2's cancel, and you're left with 1 over root 3, which if we rationalize that will be root 3 over 3. So there's a value for the tangent of pi on 6 radians. And for pi on 3 radians, or 60 degrees, again, it's sine divided by cos. Once again, to divide by a fraction, you multiply by the reciprocal, and you just get root 3. The tangent of pi on 3 is root 3. And if you use your calculator for that, if you take the tangent of pi on 3, it gives you a decimal value. Again, it's an irrational number, so you'd have to round it. But the unit circle gives us the exact value. That 205 comes from root 3. That's what root 3 is. That's where it comes from. So the unit circle gives it as an exact value, where the calculator gives you a non-repeating, non-terminating decimal, so you'd have to round it. So again, we can use these when you're asked to determine the exact value of the sine, cos, or tangent of an angle that can be found on the unit circle. Now we only have the first quadrant of the unit circle here, but that doesn't matter. So to do these, we're going to use something known as reference angles. If you want to find the sine of 11 pi on 6, so the first thing you'd want to find out is where is that on the unit circle. That's where we're going to start. So we'll start by drawing XY axes for all of these, because our first step will be to find out where the terminal arm is for each of these. So I'll do G, H, and I along the side here. So this would be for G, this will be for H, this will be for I. Okay. So where is 11 pi on 6 on the unit circle? That is a positive rotation angle. So remember, that means you have to go counterclockwise. A negative rotation angle like question B would have us go in a clockwise direction. But the first one is a positive rotation angle, so we're going to go counterclockwise, 11 pi on 6s. Pi on 6 is the same as 30 degrees. So I need to go 11 pi on 6s, or 11 multiples of 30 degrees. So that my first one would be there, approximately, at 30. Then another one will take us to 60. There's my second one. Another one will take us to 90. There's my third multiple of pi on 6. There's 4, 5, and 6 pi on 6s. That's pi, halfway around. 7, 8, 9 pi on 6s. That's the same as 3 pi on 2. And we have to go 2 more. 10, 11. So there's our terminal arm. Right there. That's where 11 pi on 6 would be on the unit circle. So if you start at 0 and you go in a positive direction, you're actually going almost one complete rotation around, because one rotation around would be 12 pi on 6s. That's 2 pi. 12 pi over 6, 12 divided by 6 would give you 2 pi. So the other way of looking at this is only 1 pi on 6 short of 1 complete revolution. That's another way we could have got that terminal arm. So this ends up in quadrant number 4, right? And we're also going to use what's known as the CAST rule. We spell the word CAST, C-A-S-T, starting in the 4th quadrant and working our way around in a counterclockwise direction. Spell the word CAST, C-A-S-T. That tells you which ratios are positive in those quadrants. A stands for all. They are all positive in that quadrant. S stands for sine. In the 2nd quadrant, the sine is positive. That means that cosine and tangent are negative there. The 3rd quadrant is our tangent quadrant. Tangent is positive there. Sine and cos are both negative. And the 4th quadrant is our cosine quadrant. Because cosine is positive there, sine and tangent are both negative. So, in the 4th quadrant where we are, we know our answer is going to be negative because that is the cosine quadrant, which means cosine is positive. Sine and tan are both negative, and we want to find the sine of 11 pi on 6. So, the sine of 11 pi on 6 will equal the negative sine, and again, the negative comes from the fact that we're in the 4th quadrant, and that's our cosine quadrant. But it's going to be the negative sine of pi on 6. So that pi on 6 is what's known as the reference angle. It is the angle between the terminal arm and the x-axis. That's where that comes from. Right? So that is the reference angle, the angle between the terminal arm and the x-axis. You're also going to see that the denominator for the reference angle will always match the denominator of the rotation angle. Because the rotation angle is a multiple of pi on 6, our reference angle is pi on 6. That's always going to happen. So it kind of takes a bit of a guesswork out to determine what the reference angle is. So now we go to our unit circle. At pi on 6, we're right here. The sine is 1/2. Remember, the sine is the y value. The first number is the cosine. The second is the sine of that angle. The sine of pi on 6 is 1/2. So in this case here, it's going to be negative 1/2 because we're in the 4th quadrant. So there's our answer. And we can check this on our calculator. We just have to make sure that we are in radian mode because this angle is in radians, which I am already. So if I take the sine of 11 pi on 6, I get negative 0.5, which is negative 1/2. You should never get these wrong because you can always use your calculator to check. So there's the first one done. Question B. We want to go negative 7 pi on 4s. Remember, negative means you're going in a clockwise direction. And we're going to go clockwise 7 multiples of pi on 4, which is 45 degrees. So if we count, there's our first multiple of 45 degrees going clockwise. Our second one will be there at the bottom. There's our third one, our fourth one, our fifth one, our sixth one, our seventh one takes us right there. Halfway between 0 and pi on 2. So this is where our terminal arm will be. We went 7 pi on 4s in a negative direction. Another way of looking at this is we're 1 pi on 4 short of 1 rotation because 1 rotation would be 8 pi on 4s. Remember, a rotation is 2 pi. 8 pi on 4 would be 8 over 4, which is 2 pi. Okay, so there's where our terminal arm is, and we need to use this along with our cast rule to tell us whether our answer is going to be positive or negative. We're in the first quadrant. That is our all quadrant. They're all positive there. So this is going to equal the positive cosine of the reference angle, the angle between the terminal arm and the x-axis, which would be pi on 4. And remember, it will match, the denominator will match the denominator of the rotation angle. So this is the cosine of positive pi on 4, which, if we look at the unit circle, that's root 2 over 2. There's the exact value of the cosine of negative 7 pi on 4, which we can check on our calculator. The cosine of negative 7 pi over 4, is that decimal. And so to check it, the answer we got as an exact value is root 2 over 2. So we'll put root 2 divided by 2 in our calculator. We should get the same decimal, and we do. So we just checked our answer. It is correct. So again, should never get these wrong. The next one, we want to do a rotation angle of positive 450 degrees. So positive means we're going in a counterclockwise direction. And you should immediately recognize that's greater than 360, so you're going to go around once and then some more. Once around in a positive direction, again, takes us to positive 360. To get to 450, we'd have to go another 90 degrees. In this case, this angle is coterminal with 90 degrees. So there's our terminal arm right there. And at that point, remember, our coordinates are 0, 1. We can also look on our unit circle below, where we've written what the value of the tangent is in black. It's undefined because you're going sine divided by cos, which is 1 divided by 0. It doesn't exist. And if you take the tangent of 450, which you'd have to now change the mode back to degrees, the tangent of 450 degrees doesn't exist. It's undefined. You get an error. So again, you can always check these on the calculator. You just have to make sure you're in the right mode. So the remaining questions are all in terms of radians. So when we check them, we're going to have to go back into radian mode. But before we get there, we have to use our unit circle to get our answer. So for question D, we want to go negative 5 pi on 6s. So there's a couple different ways you can look at this. You can go around in terms of pi on 6s, which is the same as multiples of 30 degrees. We're going negative 5 pi on 6s, so we have to go clockwise. 5 multiples of pi on 6, or 5 multiples of 30. So there's our first multiple, there's our second, there's our third, there's our fourth, our fifth one will take us right there. So here's where our terminal arm will be. Another way of looking at that, it's 1 pi on 6 short of going 6 pi on 6s, which is pi. 1 pi on 6 short of going halfway around the circle. So that's where we are. Remember, we then need to use our cast rule to tell us whether our answer will be positive or negative. In this case, we're in the third quadrant, which is our tangent quadrant. So the tangent is positive, everything else is negative. So in this case here, our answer will be negative the cosine of, and again, the reference angle will be pi on 6. That's the angle between the terminal arm and the x-axis. The denominator of the reference angle has to match the denominator of the rotation angle, which is 6, pi on 6. So our answer will be the negative cosine of pi on 6. When we look at our unit circle, at pi on 6, we're right here. The cosine is the x value, which is root 3 over 2. But because we're in the fourth quadrant, it'll be negative root 3 over 2, which we can check. We just have to make sure that we are back into radian mode. And we will take the cosine of negative 5 pi on 6. Negative 5 times pi over 6 is that decimal, which should be the same as negative root 3 over 2. Same decimal. So we just checked our answer. But we were able to express our answer as an exact value, not an irrational number, not a decimal that needs to be rounded. Try question E on your own. And if Sathuni gets it right, we'll all clap. We will. We'll clap. You don't want everyone to clap for you? Okay, I'll leave you alone. What would you do without me, Sathuni? Like, you'd be sad. You'd cry. So 13 pi on 3s. Again, this is a positive rotation angle, so we have to go counterclockwise, 13 pi on 3s. To make this a little bit easier, this is what I would do. If you're going to go one rotation around the circle in terms of pi on 3s, that would be 6 pi on 3s. Because one rotation is 2 pi, 6 pi on 3 is 6 divided by 3 pi, 2 pi. So once around the circle would be 6 pi on 3s. So another trip around the circle would be 12 pi on 3s, right? We need to do one more. And you can also remember that pi on 3 is equivalent to 60 degrees. So we're approximately right there. This is where our terminal arm would be, approximately right there. Our cast rule tells us that we are in quadrant number 1. That is the A quadrant where all ratios are positive. So this will equal the positive sign of pi on 3. Right? Our reference angle will have the same denominator as the rotation angle. The rotation angle is a multiple of pi on 3, so our reference angle is pi on 3. And we can look on our unit circle and see that at pi on 3, the sign, which is the second number, the y value, is root 3 over 2. So this will equal positive root 3 over 2. And if we checked it in our calculator by taking the sign of 13 pi over 3, you get that 0.8660, which is root 3 over 2. The one we just checked before was negative root 3 over 2, so it was negative 0.8660. This is a positive. Right? So you can always check these. Do we need to clap for you, Sathuni? I know you got it right. I know you did, so clap for Sathuni. There you go. All right. Tangent of negative 5 pi on 2. So remember, the negative means you're going to go in a clockwise direction. So you're going to go 5 pi on 2s in a clockwise direction. And pi on 2 is the same as 90 degrees. So we're going to go 5 multiples of 90 degrees in a clockwise direction. So 4 of them would take us once around. We need to do one more. So this would be coterminal with 3 pi on 2. There's where our terminal arm would lie. Now when we are on one of the axes, we don't use our cast rule because we already know what the coordinates are there. Whoops, I put that in the wrong one. Let me fix that. It's this one down here. There we go. We know the coordinates down there are 0, -1. And we also know that the tangent there can be found by going sine divided by cos, which is what we need here. We want -1 over 0, and whenever you try and divide by 0, that doesn't exist. It's undefined. So if we take the tangent of -5 pi on 2, we should get an error. And we do, because it's -1 over 0, undefined. All right, question G. The tangent of 7 pi on 3. So that's a positive rotation angle. If we go around the circle one complete time, how many pi on 3s is that, Tyson? Huh? 6 pi on 3s, right. So we need to go one more pi on 3. Again, one complete rotation in a positive direction, which is counterclockwise, is 6 pi on 3s. We need to go one more. And also remembering that pi on 3 is 60 degrees. Helps us know kind of where we should stop. So that's where we are. Using the cast rule. This is the A quadrant, which means they're all positive there. So this will equal the positive tangent of the reference angle, which is pi on 3. Same denominator as the rotation angle. And at pi on 3, we have our tangent written. It's positive √3. We got that by going sine divided by cos. And we'll check this on our calculator. The tangent of 7 pi on 3 is that decimal, which is equivalent to √3. The calculator gives it as a irrational, a decimal that you'd have to round, so it's an estimate, whereas the unit circle gives it to us as an exact value. Question H, the sine of -8 pi. So the negative means we're going clockwise, 8 pi's. And remember, pi is halfway around the circle. So in this case here, another way of looking at it, you can go 8 pi's, which is the same as 4 complete rotations. That's right. Because every 2 pi, you're going to do 1 rotation. So if you go 1 rotation every 2 pi, you have 4 rotations to go 8 pi's. So you can draw 4 rotations, but 1 rotation will take you back to where you started. Same with the second one, same with the third one, same with the last one. Complete rotations. So we're going negative, which means we're going clockwise. There's 1 rotation. There's 2. There's 3. There's 4. It doesn't matter how many times you do it, you're always going to end up at the same spot. Right there, where the coordinates are 1, 0. We want the sign, which is the second number. It'll be 0. So this one, our calculator would give us exactly the same answer as what the unit circle gave us, because it's 0. Now, sometimes the calculator does that. That's scientific notation. That's 4 times 10 to the -13. That means 0 point and then 12 zeros before there's a 4. Essentially, it's 0. I don't know why the calculator does this. Sometimes it does. Instead of giving you 0 as an answer, it'll give you a number that's very close to 0. Okay. So the last one is the cosine of positive 5 pi on 4. So do that one on your own. Did you get an answer, Leo? You got an answer? Did you check it on your calculator? What'd you get for an answer? You want to bet a pop on that? Well, you can owe me. Vish does. And Vish also knows about the concept of interest, where after so many weeks, the debt is doubled. So no, wait. You're lucky I'm not Italian. You'd have one of your legs broken already. Is he right? He said 0, Madison. Is he right? Calling him a liar? Not very nice. Okay, so you're going to go 5 pi on 4s in a positive direction. Remember, a pi on 4 is the same as a multiple of 45 degrees. So we're going to have to go 5 multiples of 45 degrees. Now, we can make this a little bit simpler. If we went 4 pi on 4s, what is that? That's 180. That's halfway around the circle. Halfway around is pi radians, and 4 pi on 4 would be pi. We need to go one more multiple of 45 degrees past 180, or one more multiple of pi on 4 past 4 pi on 4. So this is our rotation angle. Looks like that. Using our cast rule, this is the t quadrant. So tangent is positive, everything else is negative. So the cosine will be negative. And it'll be the negative cosine of the reference angle, which would be pi on 4. You want to change your answer, Leo? Yes. Because at pi on 4 on the unit circle, both the sine and cosine are the same value, root 2 over 2. But in this case, it's negative because of what quadrant we're in. And you can check that on the graphing calculator. If you do the cosine of 5 pi on 4, I think you get negative 0.707. The cosine of 5 pi on 4, negative 0.707, which is negative root 2 over 2. Okay, should never get these wrong. Okay, let's keep going here. The only thing different that we're going to do now is we're going to introduce what are known as the reciprocal ratios. Our primary ratios are our sine, cosine, tangent, right? Each of these has what's known as a reciprocal ratio. But let's start once again by labeling this unit circle, which, really, on the next page, we've got the complete unit circle. So we've only done the first quadrant, right? But you can fill in the values for the other quadrants using reference angles and the same two numbers, just with the appropriate sign. So for example, where the numbers for 5 pi on 6 come from, that has a reference angle of pi on 6. So it's the same two numbers from pi on 6, except if you're in the second quadrant, x is negative and y is positive. The numbers for 3 pi on 4 come from the numbers for pi on 4, except for, again, x is negative, y is positive. And same thing with the numbers for 2 pi on 3 come from the numbers for pi on 3 with the appropriate signs. This also, again, reinforces the CAST rule. In the second quadrant, that's our S quadrant. Sine is positive. Sine, remember, is the second number, where cosine is the first. Cosine is negative. Sine is positive. That's why it's the S quadrant. Also, tangent will be negative because it's a positive value divided by a negative. Sine divided by cos. That's why tangent is also negative in that quadrant. Right? This third quadrant is our T quadrant. Tangent is positive because both the sine and cos are negative. When you divide a negative by a negative, you get a positive. And again, the numbers for 7 pi on 6 come from the numbers for pi on 6, just with the appropriate signs. Root 3 over 2 comma a half, but now it's negative root 3 over 2 comma negative a half. Same thing with pi on 4 and 4 pi on 3. They come from the reference angles in the first quadrant. Right? So there's the entire unit circle there that you can use if you want for reference. But when it comes time for any quizzes or tests, you won't be given this. You won't be given anything from the unit circle. You have to be able to recreate it. And as we've seen, we only really need that first quadrant. That's all we really need. The first quadrant, along with the CAST rule and reference angles, is all you need. Okay? So, we have seen that on the unit circle, the sine of the angle is the y-coordinate, the cosine of the angle is the x-coordinate, and the tangent is sine over cos, or y over x. These are our primary trig ratios, but there are 3 other ratios known as the reciprocal. The cosecant is the reciprocal of sine. If the sine is negative root 3 over 2, then the cosecant would be negative 2 over root 3, the reciprocal, which you could rationalize. The reciprocal of the cosine is the secant, right? If the cosine is 1/2, then the secant is the reciprocal, 2 over 1 or 2. And the reciprocal of the tangent is the cotangent. If the tangent is 0, which is 0 over 1, right? If the tangent of theta is 0, which comes, remember, from 0 over 1 on the unit circle, then the cotangent would be the reciprocal, which is 1 over 0, which doesn't exist. It's undefined. So it's important to, especially when you're dealing with tangent and cotangent, it's important to know where the 0 comes from. It comes from 0 over 1. Just like if the tangent is undefined, that comes from 1 over 0, then the cotangent would be 0 over 1. Okay? So it's pretty easy to remember that the reciprocal of tangent is the cotan. In order to keep the reciprocal of sine and cosine straight, think of it this way. The reciprocal of sine is cosecant. So sine and cosecant go together. They're a pair. There's only one co in that pair. Sine goes with cosecant. There's only one co in that pair, the cosecant. The reciprocal of cosine is secant. So cosine and secant go together. They are a pair. There's only one co in that pair. That is the cosine. It goes with secant. Okay? And then tan and cotan go together as well. So how are the coordinates of the points on the unit circle related to the reciprocal trig ratios? Well, we know that on the unit circle we have x comma y. The x tells you the cosine, the y tells you the sine. So the cosecant, which goes with the sine, because remember, each of those pairs, there's only one co in it. So if we have cosecant, that goes with sine. The sine is found from the y value, so the cosecant will be 1 over the y value, the reciprocal of the sine, the reciprocal of y. Secant goes with cosine. Secant and cosine are a pair because, again, there's only one co there. That goes with the cosine. So the other one can't have co. It has to be secant. The x tells you the cosine, so 1 over x will be the reciprocal, which will be the secant. Cotan is a reciprocal of tangent. Tangent is found by going y over x, so the cotan will be x over y. So now, we can find the exact value of the following, and now some of these deal with those reciprocal ratios. So we will start this by, again, drawing our first quadrant of the unit circle. So at 0, we are at 1, 0. At 90 degrees, or pi on 2, we're at 0, 1. And then we have, once again, our 3 stops on the unit circle. The first one is pi on 6 radians, or 30 degrees. Then we're going to have pi on 3 radians, or 60 degrees. And in between them, we're going to have pi on 4 radians, or 45 degrees. At pi on 6 radians, or 30 degrees, remember, if you use your hand trick, that's your second finger. The first stop after 0, it's the root of this many fingers over 2, comma, the root of this many fingers over 2. Root of 3 over 2, comma, 1 over 2. And some of you will get to the point, well, just remember that. But you can always use your hand to make sure. Right? Up here at that stop there, which was pi on 3 radians, or 60 degrees. To use the hand trick, that's the second last stop. It's the root of this many fingers over 2, comma, the root of that many over 2. Root of 1, which is 1 over 2, comma, root 3 over 2. So 1/2, comma, root 3 over 2. And then that middle stop, that is pi on 4 radians, or 45 degrees. The middle finger goes down, it's the root of 2 over 2, comma, root of 2 over 2. And remember, the tangent is sine over cos. At 0, it's 0 over 1, which is 0. At 90 degrees, it's 1 over 0, which is undefined. At pi on 4 or 45 degrees, you're dividing something by itself. That gives us 1. When we did pi on 6 or 30 degrees, we got 1 over root 3, which was root 3 over 3. And again, you can do that by going sine divided by cos, 1/2 divided by root 3 over 2. And up here, it was root 3 over 2 divided by half, which was root 3. So first we want the cosine of 5 pi on 6. So we'll do these the same as we did the other ones. We will draw our rotation angle because we need to know what quadrant our terminal arm is in. That's our first step. We need to know what quadrant our terminal arm is in. So for the first one, we're going 5 pi on 6s in a positive direction, which is counterclockwise. Remember, 6 pi on 6s would be halfway around. That's equivalent to pi. We're going to be 1 pi on 6 short of that. So it's going to come something like that. That's where our terminal arm will be. Using our CAST rule, this is our S quadrant. Sine is positive. In this case, we're asked for the cosine. So it's going to be the negative cosine, and our reference angle is pi on 6. The same denominator as the rotation angle. And if we look up here, the cosine of pi on 6 is root 3 over 2, but in this case, it's negative root 3 over 2. Which again, we can check on our calculator. We just have to make sure that we are in radian mode, which we are. The cosine of 5 pi on 6 is negative 0.8660, which is negative root 3 divided by 2. Same decimal. Right, question B. The sine of negative 4 pi on 3. So that means we're going clockwise, 4 pi on 3s. Once around the circle would be 3 pi on 3s. That's pi. We need to go one more, pi on 3. And again, pi on 3 is equivalent to 60 degrees. So we're going 60 degrees past 180 in a clockwise direction. So this is where our terminal arm will be. Approximately right there. Again, the CAST rule tells us that we are in the S quadrant, which means the sign is positive, which is what we're using here. We're using the sign. So this will be the positive sign of our reference angle, which is pi on 3. Sine is the y value. The y value at pi on 3 is root 3 over 2. So it'll be the same decimals we had for part A, except now it'll be positive, 0.8660. The sine of negative 4 pi on 3 is positive, 0.8660. Let's skip down and do E and F next because they are in radians, so we don't have to switch our mode till we do the... And actually, there's more here, so that's okay. Let's switch to degrees. Secant of 315 degrees. So 315 degrees, that's a positive angle. You're going to go counterclockwise 315 degrees. So there's 90, 180, 270, 315 is approximately right there. I think that's halfway between 270 and 360. So in this case, we want the secant, which is the reciprocal of the cosine. And because this is the C quadrant, the cosine will be positive. So the secant will also be positive. And the reference angle in this case will be the difference between 315 degrees and 360 degrees, because the reference angle is the angle between the terminal arm and the x-axis. So when it's in terms of radians, It's easy to know what the reference angle is. It always matches the same denominator as the rotation, but in this case, now we're in degrees. So you need to do a small calculation to figure out that the reference angle is 45 degrees. So it'll be the secant of 45 degrees. Now, the secant is a reciprocal of cosine. The cosine of 45 is root 2 over 2. Remember, though, just to make this easier, if you can remember that that actually came from 1 over root 2, from those special triangles, it makes it much easier. If the cosine is 1 over root 2, then the reciprocal of that will be root 2 over 1, or just root 2. So to check this, we again need to change our mode to degrees. And there is no secant button on the calculator, so you must take the cosine, which is the reciprocal of secant, the cosine of 45, and then take the reciprocal, which is the x to the negative 1 button. That's the button to the left of sine. You can go 1 divided by the number that we have there, 1 divided by the previous answer, or if you go x to the negative 1, it'll do that. It takes the previous answer to the power negative 1, which is 1 over the answer to the positive 1. So that's what you get, which is equivalent to the root of 2 when you're checking it. Same decimal. So we know our answer is correct, but now we have the answer as an exact value, not a decimal. Okay, so for the next one, the cotan of 270. Well, 270 degrees, we already know where that is on the unit circle. It's right there. And the coordinates there, remember, are 0, 1. The tangent would be 1 over 0, which is undefined. But the cotan would be the reciprocal. It would be 0 over 1, which is 0. To do this on your calculator, you can't really, because when you take the tangent of 270, it gives you an error, because that is undefined. And if you try and take the reciprocal of that, let's see what happens. Yeah, it doesn't work. It takes us a reciprocal of the previous answer that actually worked, which was the 1.414. So this one you can't really check on your calculator. So you're going to have to think it through. But it comes from the unit circle, the fact that the tangent is 0 over 1, sine divided by cos. So the tangent is 1 over 0, so the cotan is a reciprocal 0 over 1. Okay. So the next one, the tangent of pi on 2. Well, pi on 2 again is on our unit circle. Right there. Once again, the coordinates there are 0, 1. And tangent is 1 over 0, sine divided by cos, which again doesn't exist. Cosecant of 7 pi on 3. So first, again, where is 7 pi on 3 on the circle? That's a positive rotation angle. To make this easier, if we go 1 rotation around in a positive direction, that is 6 pi on 3s. 2 pi. We need to go 1 more pi on 3. Takes us to 7 pi on 3. Approximately right there. Using the cast rule, this is our all quadrant. So they're all positive. So this will be the positive cosecant of pi on 3. That's our reference angle. Cosecant is the reciprocal of sine. So at pi on 3, which is up here, the sine is root 3 over 2. So when you take the reciprocal of that, which will be 2 over root 3. Or, if we rationalize that, it'll be 2 root 3 over 3, if you rationalize that. So, to check that, We don't have a cosecant button on our calculator, so we have to use the reciprocal, which is the sine of 7 pi on 3, which is that decimal, and, oh, I got to change to radians. That's better. It's that decimal, and then we take the reciprocal of it. So that would be the answer of the cosecant of 7 pi on 3, the reciprocal of the sine, but that's an irrational number. But we can check the answer we got, which was 2 root 3 all over 3. Should be the same decimal, and it is. So we know that our answer is correct. Try G on your own. Negative 7 pi on 6. So we have to go 7 pi on 6s in a clockwise direction. Halfway around the circle would be 6 pi on 6s. That's pi. We need to go one more. And pi on 6 is a multiple of 30 degrees. So there's where our terminal arm would lie. Using our cast rule, this puts us in the S quadrant. So the sine would be positive as well as the reciprocal of sine, which is the cosecant. Because this is a secant, it's going to be the negative secant of our reference angle, which is pi on 6. Secant is the reciprocal of cosine. The cosine of pi on 6 is root 3 over 2. It's the x value. So we need to do the reciprocal of that to get the secant. It'll be, once again, 2 over root 3. But in this case, it's negative, or negative 2 root 3 over 3. So we just did that on our calculator. We have that decimal there. It's that 1.154. So if you do the cosine of negative 7 pi on 6, and then take the reciprocal of that, we'll get that same decimal, only now it's negative. Okay, so it checks. The cosecant of positive 5 pi on 4. So you're going 5 pi on 4s in a positive direction, which is counterclockwise. Halfway around the circle will be 4 pi on 4s. We need to do one more. And remember, pi on 4 is the same as 45 degrees. So we're going 45 degrees past pi. Something like that. Our cast rule tells us that this is the t quadrant. We want cosecant, which is the reciprocal of sine. So this is going to be the negative cosecant of the reference angle, which is, again, pi on 4. So at pi on 4, we want the reciprocal of the sine. The sine and the cosine are both root 2 over 2. But remember, that came from 1 over root 2. And if you think about it like that, it's much easier to take the reciprocal. It would just be negative root 2. The reciprocal of 1 over root 2 is just root 2. So if we take the sine of 5 pi on 4, it's that decimal, but we have to take the reciprocal then to get the cosecant. So x to the negative 1 is negative 1.414, which is negative root 2. Okay. So the calculator gives it to us as an irrational number, but we can check to make sure the exact value we got matches. Okay. The last one, the secant of positive 11 pi on 3s. That's going counterclockwise 11 pi on 3s. So once around would be 6 pi on 3s. A second full rotation would be 12 pi on 3s. So we've got to back up though because we only need 11 pi on 3s. So it's essentially 1 pi on 3 short of 2 complete rotations. Using our cast rule, this is a C quadrant, so the cosine is positive, as well as the reciprocal of cosine, which is secant. So this will be the positive secant of pi on 3. That's our reference angle. At pi on 3, that's up here. Again, we want the secant, which is reciprocal of cosine. The cosine is 1/2. So the reciprocal of that would be 2 over 1, which is 2. If you do the cosine of 11 pi on 3, it gives us 0.5, but we need the reciprocal of that. X to the negative 1 gives us 2. So those were all exact values. If you want to determine an approximate value to 4 decimal places, you just use your calculator in the appropriate mode. So question A, cotan of 7 pi on 5. We have to be in radian mode, which we are. But we have to first take the tan of 7 pi on 5, and then the reciprocal to get the cotan. So to 4 decimal places, it'll be 0.3249. To 4 decimal places. Let's skip and do question C now, because that's also in radians. Remember, if there is no unit given, it means radians. The first one is in radians because it's multiple of pi. The middle one is degrees because you got that degree symbol there. But C is radians because there's no interest, or no unit given. We want the cosecant, which is the reciprocal of sine. So we'll start by first taking the sine of 4.2, and then the reciprocal of that. Negative 1.1473. Rounded to 4 decimal places. The middle one is degrees, so we need to be back in degree mode. The reciprocal of secant is the cosine, so we'll take the cosine of 260 degrees, and then the reciprocal of that. Negative 5.7588 when you round to 4 decimal places. And you should realize that none of these angles are on the unit circle. They're not a multiple of 45 degrees or 30 degrees or any of those other ones, right? So you cannot find these on the unit circle because those angles are not there anywhere. All right? So this 4.3 is what you're going to do, and you're going to hand it in. Okay? So exact values, as it says, so you're using the unit circle at first quadrant, and you're using reference angles for some of them. Okay? So this one's going to get handed in for marks. Yep.